For a little over a year, Iceland's most dangerous volcano known as Katla has been producing a slightly elevated number of shallow earthquakes, including several weaker earthquake swarms. Then, on May 4, 2023, beginning at 9:40 a.m. local time, an unusually energetic earthquake sequence began. This sequence began with two earthquakes that were less than magnitude 2 before being followed by the largest earthquake to hit this ice-covered volcano in 64 months, at magnitude 4.5. Two more magnitude 4 events followed in the next 5 minutes, including the largest earthquake to have struck Katla since at least 2009, a magnitude 4.8. More than 30 smaller earthquakes also occurred, and as a result, Katla's alert level was raised from green to yellow, and an uncertainty phase was declared around the volcano. While this activity is unusual, it is not unprecedented. Two similar earthquake storms occurred during 2016, one on August 29th, and one between September 29th and September 30th. These 2016 swarms each involved more earthquakes than the current swarm, but the largest earthquake was slightly lower in each case than the ongoing earthquake swarm. With all of this taken into account, the earthquake swarm at Katla, at least for now, seems to be a once-in-a-5-year event, with a similar event occurring about once every 5 years. What made the latest swarm all the more suspicious is that the earthquakes almost universally appeared to occur at a depth of less than 1 kilometer, marking them as incredibly shallow. When earthquake storms of this magnitude occur, there are generally 4 possibilities. The first is that a fault line moved due to non-volcanic activity, triggering a movement at other faults. However, these earthquakes are seemingly centered on the northeastern edge of Katla's large caldera, so this seems unlikely. Possibility 2 is that a large influx of meltwater is moving through the volcano, either due to increased fumarole temperatures beneath the ice or meltwater related to unusually high temperatures. Yet, there does not appear to be any signs that Katla's glacial ice is sinking, which would be expected during the beginnings of a glacial flood known as a jökulhlaup, and the temperature on top of the volcano is still a cool 3 degrees Celsius. Possibility 3 is that magma is intruding into shallow depths underneath the volcano. This possibility cannot be immediately discounted, although if magma was at shallow depths, you would expect ground deformation above the intrusion center, in addition to an increased release of volcanic gases and the detection of harmonic tremor. Additionally, the quakes seem a bit too shallow to represent a magmatic intrusion if one was occurring. None of these 3 features have been detected as of yet. Magmatic quakes would probably start around 2.5 kilometers beneath the top of the volcano and then migrate upwards. Therefore, in my opinion, the 4th possibility appears for now to be the most likely culprit, that a small to moderate change occurred in Katla's hydrothermal system. Due to the overlying glaciers and combination of groundwater, hydrothermal fluids in the ground are heated when they encounter rock overlying an active magma chamber, which indeed exists beneath Katla, albeit at 2.5 kilometers depth. This rock heats the water, which carries volcanic gases along with it, causing it to be pushed upwards and reach the surface, but sometimes along the way encountering a fault line, causing it to rupture and generate an earthquake. The magnitude 4 earthquakes which occurred on May 4, 2023 were merely 3 orders of magnitude larger than what is typical, with the aftershocks not representing additional hydrothermal activity, but rather stress release due to the aftershock itself. This fact is best displayed via when the recorded aftershocks occurred in terms of the number of minutes after the main shock, as it somewhat closely follows the expected 1/x integral rate of aftershocks. Thus, on my 0 to 10 opinion-based volcanic unrest scale, I am placing Katla at a 2, with a possible case being made to raise it to a 3. Due to all of this activity and the small but present chance a volcanic eruption could still occur, several roads leading to the volcano are closed off, with many of them being in the middle of pathways historic jökulhlaups have taken. Thanks for watching. If you would like to request a specific topic, please leave a comment below. Additionally, I would like to thank Newman Bruins for becoming a new patron on this channel's Patreon page.